My background is that I'm a mechanical engineer. I'm an alumnus of this institute of IIT Madras, and the whole thing started around 2005 as a investigative project by IIT Madras, where we were trying to see how to leverage information and communication technology to cover people who are not covered by banks towards financial inclusion. And when we did this investigation, we tried different options using the internet access points as places from where people could avail loans or maybe insurance and things like that. And finally came to the conclusion that you need to have the equivalent of a bank branch, which does the bread and butter transactions of deposits and dispensation, withdrawal, for the bank to actually own a customer and build a credit history, and then later on sell all the other value added products like loans and other things. And this was not possible in the conventional model of brick and mortar branches, obviously, because the number of transactions will be very few and the ticket size of each transaction will be small. And when we tried to see how we could address it through technology, the obvious solution was to replace a bank with an ATM. But then we found that a conventional ATM doesn't work for a number of reasons. For one, the places where we put the wanted to put the ATMs were chronically power deficit. There were long hours of power outage, and this meant that you needed a huge backup power, diesel generator, and the cost was simply unaffordable. That was one problem. And the other issue was that unless the quality of currency is very good, the paper notes tended to get jammed, and then you needed to bring a specialized person in an armored truck, and reaching this place would take a day, and till then the thing will be out of service. So we needed a machine which can reliably handle commonly used qualities of currency, because you are not going to get new and crisp notes from a bank chest in these remote locations. And like this I could go on and on. We found that basically we needed half a dozen new features at least to make an ATM functional in the kind of locations where we wanted to put it. And that's when we said, okay, we need to build an ATM meant for Indian conditions ground up. And that's how the whole thing started about 2005, 2006. The challenge was big, that we wanted to make an order of magnitude difference in lot of the performance specs. We wanted to bring down the power by 100-fold or at least 10-fold and things like that. Obviously, if I had looked at a conventional design and then seen how to do modifications in it, it would be practically impossible. Fortunately, I or the other people in our team had no idea about how legacy ATMs worked, and so we were able to think afresh. And what we did was try to model the entire mechanism on the basis of how we count currency using our fingers, which is just a few watts of power. Fingers can't generate more than a few watts of power, whereas ATMs at that time were taking close to 1,000 watts. And for an engineered product, it's a shame that what you can do with a few watts, you should spend 1,000 watts. And what compounded the problem was that the entire mechanism had to be in a thick steel shell for security reasons. And 1,000 watts consumption meant 1,000 watts of heat being generated. And that would make the entire mechanism and the electronics malfunction or stop functioning. So in order to keep the machine cool, you needed to invest another couple of 1,000 watts for air conditioning the whole place, so that temperature buildup doesn't happen. And so we felt that if we could bring down the power to a few tens of watts, including the monitor and everything, then you wouldn't even require cooling, so you don't need air conditioning, there will be no temperature buildup, and that's the kind of solution that would fly. And so we modeled everything after how a human teller would dispense currency, and built a mechanism that mimics that action, and use natural forces like gravity and other things to the best advantage, so that you don't have to have heavy powered motors. And our philosophy in building the mechanism was less is better. So we probably have 10 times fewer parts in our design than any conventional ATM that you will find in the world. And the fewer the parts you have, not only are you more energy efficient, you also have, you're also probably much more than 10 times more reliable. So there is hardly any breakdown possibility, because more parts means more things can go wrong. And when things go wrong in a remote location, the turnaround time to fix it is much larger. So if you have to maintain what is called the uptime or the availability of the ATM, then you need to have something which is very reliable, has very low failure rates, and that's possible only with having very few parts. And as a consequence of all that, of course, the cost also went down. You're using less power, less parts, smaller sized motors, so the overall cost of manufacturing also comes down. So we didn't start off by explicitly focusing on a price advantage, but the price advantage was a fallout of energy efficiency and reliability. In some ways, commercializing was a bigger challenge than even building the technology, because the ATM is not a standalone product. It is something that plugs into a pre-existing ecosystem of the financial architecture of a bank. The bank already has what's called a core banking system, and then the ATM connects to it through an ATM switch, and a lot of these, there were legacy systems in place, and whatever we had to build had to be compatible with it, even if making it compatible is actually a suboptimal solution. We still had to comply with that because it had to work within that ecosystem. We cannot change the entire ecosystem overnight. Making it compliant with the pre-existing ecosystem in many ways actually eroded the advantages that we would otherwise have been able to provide. This was a challenge, and fortunately for us, in the recent past, a lot of new initiatives, be it Aadhaar, be it the Jan Dhan Yojana, or the new breed of white label ATMs and payment banks, a lot of these things are not so shackled by the conventional architecture, and they are affording a lot of opportunities to disrupt the ecosystem through very radical innovation, and I think inherently we have a lead there. So whereas in the legacy environment, we were our own technology edge was there, innovation edge was there, but it was relatively limited because we had to plug ourselves into a pre-existing ecosystem. Now we will be able to blaze very new trails, and I think the year ahead will be a lot more exciting than what we have done in the past. So see, within the last about a year, we have launched 3-4 different products, if you can call it that, different configurations of the ATM. Most recently, we launched, in response to the white label and small payment banks initiative, what is probably the world's smallest ATM, what we call as the EcoTeller Mini. And before that, we launched through the wall ATM, which is not very common in India, but is common in certain other countries, where you have an ATM looking out into the street, whereas the mechanism is inside the premises of the bank, and people don't even have to enter the bank, they just transact from the sidewalk and move on. The other product that we launched prior to that is called the EcoTeller, which is a full-fledged 4-cassette ATM, but at a very radically lower energy point, which is meant for deployment almost anywhere where you find a conventional ATM that is deployed. And we are now launching certain software solutions which will enable small banks and cooperative banks which do not have a core banking system to connect to a common cloud-based solution without big investments in either a core banking system or an ATM switch, using very contemporary web-based technologies, which will help small banks to quickly scale up to the extent that they want. Otherwise, the conventional solutions which come with a very large upfront investment are not viable unless the bank is going to have thousands of ATMs. Now, small entities like cooperative banks and others also can quickly ramp up. So these are some of the innovations that we have launched and we will be launching in the near future. Something like 150 million people have been brought into the banking fold through the Jan Dhan scheme in the last year or so, and all of them will require a suite of services, not necessarily the same services that conventional bank customers had, and I see that technology will have a very key role to play in delivering services to them in order to not only deliver the services, but deliver them at a price point that is affordable by them and in a manner which is readily scalable. So, I do not think anywhere else in the world you have added 150 million people in less than a year, and while the accounts are there, a lot of potential of what can be done through those accounts is not being done today simply because solutions have not been tailored for them. On textiles, we looked at the problem primarily that small producers, cotton growers, weavers were facing. They were all leading a very marginal existence. We are all aware that periodically there are these depressing reports about farmers committing suicide and stuff like that. And when we looked at this industry as a whole, we found that textiles is the largest employer after agriculture, and as a domain, it is the largest category of aspirational products. Something like 1 in every 3 apparel is sold through organized retail format, which is not true of food and things like that. The end customer, in terms of willingness to pay for good products, the market is very large, and yet the people who are making those products are leading a very marginal existence, and this is due to a lot of structural problems and disintermediation and end-to-end flow of material not being streamlined, which makes it very wasteful. So, we have developed a patented technology by which you can enable a small group of farmers to add value to the cotton, make it yarn, and then dye it, weave it, make end products all in a local area within a village, and have a turnover of something like 15 crores or 20 crores annually, enabling the primary producers to capture a much larger span of the value chain locally rather than merely selling the primary produce. So, this is an initiative that is being driven by another company that I founded called Microspin, and the third company that I have founded is called Skillvery, which is focused on using technology as a means to deliver skill training. The idea being that when we look at textbook and blackboard kind of knowledge, a lot of things have improved in maybe the last 10 years or so through what is called e-learning. You have text and visuals and all of that communicated online, and people can access those, they can access the best of lectures and learn at their own pace. Whereas when it comes to what are called hands-on skills, if I were to talk about plumbing or painting or welding and things like that, we are still teaching people the way things were taught 200 years ago, and it's an extremely wasteful and expensive way of imparting skills on the one hand, and on the other hand it requires students to commit a very long period of time to skill acquisition. They will spend 1 year or 2 years. So, the idea was, can you use technology to impart such skills in much shorter time, maybe in a month, 2 months, and at very low cost, so that the throughput of skilled persons increases tremendously. And the statistics is that formally trained skilled persons today annually are contributing to only 2% of the needs of the economy. So, 98% of the people are just informally absorbed into the workforce, and they learn, often badly learn wrong practices, and this is a big challenge. And I believe that this initiative of ours to use simulators as the means of delivering training which is exact and measurable will be a key driver of the Skill India initiative that India is now launching.